momentarily. Here we go. You get it attached there?
Yes, ma'am. Got it. It's loading.
Okay. Awesome. Hey, Brinley, we are going over quiz number 2, sections 13.3 and 13.4. If you have the quiz, you're welcome to pull it out, or you can just follow along on the page here. All right. Ethan and Brinley, are y'all ready now?
Yes, ma'am. I'm ready.
I think you're muted, Brinley. Oh.
Yes, ma'am.
All right, so here you go. Here are the answers, numbers 1 and number 2. You're finding the area. So number 1 is pretty simple. Area of a circle is pi r squared. They give you the diameter, so the radius is half of that. Number 2, they give you 2 semicircles and a rectangle. Well, the area of a rectangle is length times width, or base times height, 4 times 2. And then you've got this half and this half, which, well, this whole length right here is 4, which would be the diameter of the half circle for both sides. So therefore, the radius of each half circle is 2. And if I were to put those 2 half circles together, the radius is the same. So therefore, I can make it just 1 full circle. Number 3, you're finding the shaded area, so you need these 4 little pieces. So you'd have to find the area of the outside square minus the area of the circle. Well, the area of the square, how do you know what the sides are? Remember, the diameter, the length of the whole circle is 6, so therefore that coincides with the side of the square. So the sides of the squares are all 6 as well. Number 4, have to take the area of the whole outside and subtract this little cutout here. So we're just finding the area of the shaded region. They give us the radii for both of those. Hopefully that wasn't too difficult. Finding the radius if you're given the area. Oh, plug it into your formula. Area equals pi r squared. Make sure you take the square root to find just r. Similar polygons. Now we're dealing with our perimeters. So what would the ratio of the lengths of their corresponding sides be? Well, if their ratio is 4 to 9, then the ratio of the perimeters are equal to the ratio of the corresponding sides, and vice versa. The ratio of the corresponding sides is the same as the ratio of their perimeters. So those go back and forth. They're both the same. Not for area though. So that's number 7. The ratio of the areas of the triangle. Well, if the corresponding sides are 4 to 9, then the areas would be 4 to 9 squared, which would be 16 to 81. Any questions on page 1? Okay. Here we've got similar triangles that tells us that triangle ABC and triangle DEF are similar to one another. So that means their corresponding sides are, we can make proportions with them. So the ratio 6 to 9, that would be the ratio would be 2 to 3. But anyways, it gives us the perimeter is 14 inches. So therefore, what would be the perimeter of this one? Remember, if I have corresponding sides 6 to 9, I can set that equal to the triangle's perimeters. So the perimeter of triangle ABC needs to go in the numerator. Therefore, I can solve for the perimeter of the second triangle, which is 21. Make sure you have inches. You need your units. Number 9, what if I'm given the area of the triangle? Remember, the area is equal to the square of the corresponding sides. So the corresponding sides, here they just flipped the proportions. They had 16 and 6 in the denominator instead. Is that fine? Sure. Squared that, 81 over 36, cross multiply, solve your proportion. So the area is 36 square inches. Make sure you have square inches because you're finding area. Any questions on 8 and 9? Okay. And then number 10. In the area, we talk about areas are similar with polygons, not just triangles similarity. We can have parallelogram similarity as well too. So if the area of the larger parallelogram is given, what would the area of this little parallelogram be? All right, this one is a little bit tricky. So the ratio of the corresponding sides. Well, so take a look here. This side, A divided by 3, this one corresponds to the side of the bigger parallelogram, which would be, well, it's also A, so this side is A as well too. So A over 3 over A. Well, what's A over 3 divided by A? That's A over 3 times 1 over A. A over 3 divided by A is the same as A over 3 times 1 over A, which would reduce to 1/3. So that's how they got the ratio of the corresponding sides. So my ratio of corresponding sides is 1 to 3, or 1/3. Now that I have my ratio of corresponding sides, I can now find the area. So the area of the smaller parallelogram over the area of the larger parallelogram is equal to the corresponding sides squared, which 1 over 3 squared is 1/9. Well, they gave us the area of the larger parallelogram, which is 108. I can plug that into my proportion, and this area of the smaller parallelogram is 12 square centimeters. You could have also found your corresponding side ratio by doing side B over 3 over the corresponding side of B, which would be this part up here as well too. And still, 1/3 would still be your ratio. All right, this one you have to know the area formula for a, that's actually a rhombus. No, excuse me. This one you would have divided into 2 triangles. Anybody get number 11 right? Or try it? That's fine, that's bonus. Number 10 is probably only going to count half as well too, just because of the difficulty of that problem. So that is quiz number 2. Let's get into homework then. Here we go. We're finding the surface area, prisms, and cones. So here we go. Let's just start with, oops. Let's start with number 2. It says, find the surface area of the following cubes, where E represents the length of the edge. Well, the surface area of a cube is going to be much simpler than finding the surface area of a rectangular prism or a cylinder. The formula for the surface area of a cube, think about a Rubik's Cube. If you were to pull out a Rubik's Cube, or let me see, I do not see a cube, or an ice cube. Think about it. All of the faces and the bases, whatever bases you see, they're all squares. So if they're all squares, then that means the edges, so the points where 3 or more of those faces come together to touch, those edges, which represents the letter E, all of those edges, therefore, are going to be the same exact length, right? Just like if I have a square right here, all the sides are the same. Well, if I have a square cube, then this side is going to be the same. All the sides, and remember, these are called edges, so that's where they get E from. So the surface area of a cube is going to be E cubed. That's saying multiplying, here's my base, my length times my width, or S times S, S squared, times the height. Oh, no. I'm thinking of volume. I'm sorry. Wrong formula. That's for volume.
When me and my mom were doing it this morning, I was having a hard time understanding it. So she just gave me like a different way to do it than the book did. So I don't know if like it's the same. But
Are you talking about for numbers like 2 and 4 or for all of them?
for all of them,
Okay,
I wasn't really understanding the formulas.
that's fine.
So
We're going to go over that way, the way that the book is going as well too. But I want to see how your mom taught you as well too, because if that way is easier for you, then by all means, whatever makes more sense to you will work for me. So this is just the formula for a cube. That's something to memorize. The surface area of a cube is 6 times E squared, because how many faces are in a cube? Well, and bases, 1, 2, 3, 4, 5, 6. There are 6 different faces on a cube, right? So that's where we get our 6 from. E squared, well, remember, finding the surface area is saying, okay, let me find the area of all 6 of those squares and add them all together. Well, the area of all the squares is going to be the same area. So if I find the area of one square, which the area of a square is S squared, then I can just say, well, how about 6 times that area then? E is almost like the same as S, what your S would represent in your area formula. E just represents the edges, because that's what we say when we've got a cube or a square prism. So therefore, number 2, if they give us E is 7.5, 7.5 squared times 6, that will get us a surface area of about 337.5 square feet. Number 4, they give us E is equal to 2.5 meters. Therefore, this is it tells us that it's a cube, so the surface area of a cube is S times E squared. The surface area is 6 times 2.5 squared. Surface area for number 4, this cube is going to be 37.5 square meters. All right, so this is the surface area formula for a cube. Let's go to number 6. Okay, here we go. What kind of figure, Ethan, is number 6? What do we have?
A rectangular prism,
Okay, why is it a rectangular prism?
because the bases are rectangles.
Yes, the bases are rectangles. And how do we know that? Well, look at the base. The base is 5 meters by 3 meters. If that was a quarter base, then both of these would be the same. So this is a rectangular prism, and it gives us a height of 5 meters. All right, so when we're dealing with surface area, this is a rectangular prism. So my formula is S is equal to L plus 2B. Let's see here. What does L represent? Well, L represents the lateral faces. So remember, if I have my tissue box, remember this is a rectangular prism. My tissue box, what is represented as L? Well, L is going to be the lateral edges, which are the 4 faces on the side. The bases are the top and the bottom here. Those are my bases. We'll talk about that in just a second when we get over here to our second part of our formula. So I want to find the area of this piece, this piece, this piece, and this piece. That's what I'm finding for surface area. But they've given us a very simple way to find the area of all of those lateral pieces. Remember, lateral means up and down. So in order to find the lateral surface area, L, of a rectangular prism, that's going to be the perimeter times the height. Well, the perimeter of what? What is this perimeter talking about? The perimeter of the base. So let's take a look here at the base. I've got 5, 3. Remember, perimeter is the distance around an object. So that's going to be 5 over here and 3 over here. Well, the perimeter of a rectangle is 2 times L plus W, and then we'll multiply that by the height. So let's find the perimeter. Perimeter, the length is 5, the width is 3. What is the height? The height of what? Oh, the height of the prism, which is 5. So the lateral surface area is going to be 80, let's see, what are my units? 80 meters squared. Everybody with me on that? So we have found the lateral surface area. We have found the area of the 4 faces on the side of this rectangular prism. Now I want to find the area of the bases. So this top base right here and this top base right here. And remember, because it's a rectangular prism, the area of the top base is going to be the same as the area of the bottom base, which is why we can just find the area of one of the bases and multiply it by 2. So the base is a rectangle, so the area, we'll say area of the base is equal to base times height. So B is equal to, the base is 5, the height is 3. If it helps to keep it separate, you can do length times width, because I don't want you to get confused with that H meaning the height of the prism. No, we're just trying to find the area of the base. So the area of one of these bases is going to be 15 square meters. I now have my L, my lateral surface area, and I have the area of my base. So let's plug those values in. Let's find the total surface area. It's going to be 80 square meters plus 2 times the area of the base. So that's 80 plus 30, which is 110 square meters. Brandley, let me ask you this. Did you find, did your mom show you a different formula to use?
Yes, ma'am. We did
Yeah.
We did S equals 2 times the width times the length plus the height times the length plus the height times the width.
That will get you the same exact thing. Yep. That will work for a rectangular prism.
We couldn't find one though for the triangle, so she just explained it more to me for the triangular one. But
sure.
Yeah.
But you are exactly right. This will work for a rectangular prism. Good. All right, let's do another one. Let's do number 10 then. Oh wait, we did that one in class yesterday. Let's see here. So number 8 would be 88 square meters. Did we get that one correct? 88 square meters?
No.
Uh-oh. Okay. S is equal to, so this is a rectangular prism. We look at the base there, that's a rectangular base. So let's find the lateral surface area. Ethan, what's the lateral surface area equal to?
The perimeter of the base plus times the height.
Times the height. There we go. So the perimeter of the base, well, the base is a rectangle, so that's 2 times L plus W times the height. What is the length and width of the base, Ethan?
It is, I'm sorry, 4 and 2.
4 plus 2. And what's the height?
6.
There you go. So what is the lateral surface area?
72.
72 square meters. Now let's find the area of the base. Again, the base is a rectangle, so length times width. The length is 4, the width is 2. So the area of the base is 8 square meters. Let's plug that into our formula. Surface area is equal to 72 square meters plus 2 times the base, which is 8. 72 plus 16, surface area is 88 square meters. Do you see what you did wrong?
Yes.
Yeah.
I think I read the formula wrong
Oh,
for
okay.
the surface area. It says the combined area of the two bases.
So that's saying 2 times B.
So I was doing, for the surface area, I would do the lateral plus the area plus 2 of the areas and then multiply that by 2.
Times 2. Gotcha. That makes sense. Okay. Well, that's a minor mistake to fix. So good. Let's do number 7 together. What kind of prism is number 7, Brinley?
It's a triangular.
It's a triangular prism because it's got triangle bases. Well, what's the formula for the surface area of a triangular prism? Well, what do you know? It's the same as the prism of a rectangular prism. So let's find the lateral surface area first, which is perimeter of the base times the height. But now the perimeter, or excuse me, the base is a triangle, so the perimeter of a triangle is just all 3 sides added together times h. And what are the 3 lengths of my triangle on the base, Brinley? What are the 3 lengths?
Um, 7.2, 12, and 14.
There you go. You had to look at the top triangle base in order to get that 14. And what's the h stand for? Is that the height of the triangle?
It's the height of the sides.
The height of the prism. Yes, don't get that confused, because when we find the area of the base, remember the base is a triangle, so we're using 1/2 base times height. That height right there is going to be different from this h right here. This is the height of the prism, which is what?
16.
Yes. So the lateral surface area of this triangular prism is going to be 531.2. All right. Now let's find the area of the base. Again, it's a triangle, so now we're using the area of a triangle. 1/2 times, what's the base of the triangle, Ethan?
7.2.
7.2. What is the height, Brinley?
12.
Yes. Notice that top base in your picture. It's got a right angle down in the bottom corner, which means if it's a right triangle, that means that you have your height right here, and your base here. All right, so now let's just solve. 1/2 times 12 is 6. 6 times 7.2, that's going to give you an area of 43.2. Now let's plug that into my formula. The lateral surface area plus 2 times the area of the base. We would get a total area of 617.6 square centimeters. Any questions on number 7? All right, let's do a couple more. We did number 10 in class yesterday. Let's look at number 12 then. Find the length of an edge. So remember, edge is represented as E, and we're dealing with a cube. So the surface area of a cube, they give us the surface area, number 12, as 96 square inches. So remember our formula, the surface area of a cube is 6 times E squared. We've got 6 different faces on a square cube, or excuse me, a square prism or a cube. E represents S, but because we're talking about a 3-dimensional figure, they're actually the edges of it. All right, so we're looking for E. We have been given the surface area, so let's plug in 96 for S, and let's solve for E. So divide both sides by 6. 96 divided by 6 is 16, is equal to E squared. Take the square root of both sides. Therefore, the edge of one of my cube, where the length of one of my edges is going to be not just 4, but it's going to be 4 inches. Make sure you have those units down. So 4 inches. Is that Kaylee?
That was my Mimi. She came. Bye.
All right. Any questions on number 12? Did we get that one correct? Okay, good. Number 14, now we're looking for the lateral surface area of the triangular prism with the following measures. Okay, so we've got triangular prisms. So look back at number 7 and number 10. Those were triangular prisms. Just for our own reference, how many bases do we have in a triangular prism? How many bases? We have 2, okay? And let's see here. And I don't want to, I hope I haven't confused you, but I've kind of differentiated between faces and bases. Bases. But here's what I want to differentiate. A face, the face of a polygon, is a base, okay? So those things are the same. Now the bases are the top and the bottom. The faces are the things around on the side, but a face can also be called one of the bases. That being said, how many total faces do we have in a triangular prism then?
6.
Not 6. We do have 6 in a rectangular prism and in a cube, but we only have 5 faces for a triangular prism. We've got the 2 on top, and then because it's a triangle, there's only 3 lateral faces. So do you see the difference between faces and lateral faces? There's only 3 lateral faces, but there are 5 total faces. And then that includes the 2 on top, which we also call the base. Anyways, hopefully that's not confusing. So number 14, we are looking for the lateral surface area. We've got triangular prisms we're dealing with. Number 14, they give us the base is 6, 7, and 8. So I can kind of just draw a triangle over here. This is side 6, 7, and 8. This is the base of my triangular prism, and they give us the height, which is 10. So if I wanted to, I could finish drawing this triangular prism just to give me a heads up. So let's see here. Ooh, that is really bad. So I would want to draw congruent triangles, which I did not. And then I would just attach them. So there we go. This is side 7, 8, and 6. And then the height is going to be 10. So feel free to draw a picture to get a clear thing in your mind. All right, we're looking for the lateral surface area. Well, in order to find the lateral surface area, that's equivalent to the perimeter of the base times the height of the prism. The perimeter of the base is all 3 of the triangle sides added together times the height. So here we go, 7 plus 8 plus 6 times 10. My lateral surface area is going to be 210 square units. So if they don't give you specific units, you want to put square units there. 210 square units. All right, let's go ahead and do number 16 then. Actually, number 16 is pretty much the same thing. So let's move on to one of our cylinders now. So the surface area of the cylinders.
I didn't finish 18, 20, or 22.
That's fine. Let's do some of them together then. All right, because this is a little bit harder. So the surface area of a cylinder, what do you know? It's the same exact formula for the surface area of a triangular prism, rectangular prism, but the lateral surface area, instead of the perimeter times the height, it's going to be the circumference times the height. Circumference of what? The circumference of the base. And remember, the base is a circle, which is why we're doing circumference and not perimeter. We don't find the perimeter of a circle. So lateral surface area is equal to 2 pi r, which is the circumference of a circle, times h. So 2 pi r h. Let's plug in our values. What is the radius for number 18?
4.
4. And Ethan, what's the height?
7.
Yes, so here we go. Let's keep it in terms of pi for right now. So 2 times 4 times 7, that's 56 pi. So we've got 56 pi, and this is centimeters cubed. So we found the lateral surface area. Now let's come up here and find the area of the base. Well, what kind of image is my base? It's a circle. So in order to find the area of the base, I need the area of the circle, which is pi r squared. My radius, we already said, was 4. So the area of one of the bases is 16 pi. Now let's put that into our surface area formula. 56 pi is my lateral surface area plus 2 times 16 pi, because we have 2 bases, top and bottom. Therefore, 56 pi plus 32 pi will get me a total surface area of 88 pi square centimeters. And then you can change that. You can put it in decimal form. So let's see. It would be roughly about 276.3 square centimeters. And I would take either answer if you left it in pi or put it in decimal form. All right. What do you think so far? Is this helping to really simplify or ground those formulas? And Brinley, for rectangular prisms, you're more than welcome to use that other formula because that one makes sense as well too. All right. Now, Brinley, if you were to, so like on number 14 and 16, those were finding the lateral surface area of a triangular prism. Now it could flip on you and say, we'll find the lateral surface area of a rectangular prism. And if that's the case, you would have to use this other formula right here.
Okay.
You would just have to use the formula equals pH, right? So both ways work. Let me see what I want to do. What I want to do. Okay. Here we go. If you didn't finish last night's assignment, go ahead and finish that up for your assignment as well too. And then I want you to do 1 through 25, the odds. Numbers 1 through 25, the odds.
On the same lesson?
Yeah. Yeah. We won't have a quiz just yet. We'll get through 13.6 as well. All right, so finish up last night's assignment, 1 through 25, the odd, and that will be it for today. All right.